In this short section, we will look at atomic emission spectrometry or AES. In AES, the atoms in the sample will be excited into high energy levels, and these atoms would then fall back to the lower energy levels, and as they fall back, they will emit light of a characteristic wavelength. So this light will be measured by the spectrometer, and the intensity of radiation will be proportional to the concentration of the sample. So let's look at what happens inside the atomic emission spectrometer. The sample is typically in an aqueous solution. So first of all, the sample will be vaporized and atomized in a flame. Besides a flame, some spectrometers also use plasma as the heat and excitation source. So atoms will absorb energy from the flame and would be excited into higher energy levels. When these excited atoms return to the ground state, they would then emit radiation of specific wavelengths. The radiation would then go into the monochromator, which would separate them according to the different wavelengths. Then the light from each wavelength will be detected at the detector. AES is used mainly for the quantitative determination of alkali metals such as sodium, potassium, lithium, etc. Calcium can be determined by AES as well. In AES, all the atoms in the sample are excited simultaneously when they reach the flame. Theoretically, they can be detected simultaneously as well, and this is an advantage of AES compared to AAS. Remember, in AAS, we have to use a different lamp for each different element. For example, if you want to detect sodium, then you have to use a lamp which uses sodium as the source. And if you want to detect potassium, then you have to use a different lamp which uses potassium to generate the light source. But in AES, we don't have to change the lamp. In fact, there is no lamp. So some instruments are used to detect sodium and potassium at the same time. This is an illustration of an AES spectrometer which can be used to detect both sodium and potassium in blood serum. So first of all, the sample is atomized and excited. This sample contains both sodium as well as potassium. As the excited atoms fall back to the ground state, they will emit radiation of specific wavelength. So there would be a specific wavelength for sodium and a specific wavelength for potassium. The beam coming out can be split into two, one going to the detector for sodium and another one going to a detector for potassium. So both sodium and potassium can be determined simultaneously in that sample. So if we were to use AES to determine the concentration of sodium in a sample, how would we do it? First, we would need to prepare standard solutions with different concentrations of sodium ion. So we could prepare different concentrations of NaCl. The spectrophotometer would also need to be set up according to the operating instructions. Then the instrument will be auto-zeroed using the blank, and the emission intensity of the different standards would be measured. With this, we can construct a calibration curve and use it to determine the concentration of the samples.